here there's a number line, and obviously I have 0, 1, 2, 3, 4 going up and even, just to sort of recap, right? You have your fractions that are kind of in the middle, um, like a half, and then in between each one. But nevertheless, we have been on the positive side. Newsflash, there are numbers that are less than 0, and those are our negative values. So coming this way, let's say -1, -2, -3, and so forth. And we will draw the ray going in the negative direction. So negative, and this is positive. So we now sort of have this realm of negative values. So obviously, with that in mind, we're going to rehash some operations as covered at the beginning. So first and foremost, addition. If you add a negative number, it is the same as subtraction. So 1 plus, I don't know, -2. And I'll even do this so that we can see clearly that it's a negative number. And that will be -1 as an answer, right? So essentially, we are playing a game of opposites. And likewise, if we subtract a negative number, it is the same as adding. So now, right, 1 plus, oh, excuse me, 1 minus -2. And that is the same as adding because you are subtracting away a negative value. So that is 3, right? And the equivalent expression for each of these, right, you could really just have it as 1 minus 2, which again is -1, and then 1 plus 2, which is 3. So you can sort of think of a negative number as essentially -1 multiplied by a positive value, and then flip signs. Multiplication, the rule is if you multiply a negative number by itself, right, let's do -2 and -2. By the way, parentheses are also multiplication. You're going to see that often. -2 times -2 is simply 4. You multiply two positives together, two negatives together, it is positive. Likewise, if you multiply a negative by a positive, it is a negative value, and it'll be -4. So essentially that is the case. For division, it is the same. Divide a positive value by a negative value. So 2 divided by -2, it will be a negative number, so -1. If you divide a negative value by a negative number, it is a positive result. With a negative value, and you see this number line, it comes the concept, essentially, you want to know how much of something you have, regardless of the sign. So let's say, for example, and really, let's say we're at 0. Hey, my house is here at 0, and I travel this way to 2. So I'm 2 blocks away from my house. Okay, cool. What if I travel in the opposite direction? Yes, I'm to the left of my house, but I'm still 2 blocks away from my house. So essentially, I'm still at the same distance from my house. And that sort of expression that we can write, hey, well, let's say I'm at -2, right, on this number line. And I write this bar looking thing around it. This is referred to as the absolute value of a number. The absolute value, essentially, it is hey, what distance have I traveled? Regardless of which direction you travel, you're traveling a certain distance, and that distance is the positive value. It'll always be positive. So, hey, even if it's -2, hey, I've traveled 2 blocks from my house, regardless of the direction. So there you have it. Hey, what's the absolute value of, I'll slide up here, -6? Hey, it's 6. What's the absolute value of 3? It's 3, because it will always be positive. So that is something for you to note. Absolute value. All right, continuing down the line of operations, we revisit powers. First and foremost, the base number, which is the bigger number that is being raised to something, right? If you have this notation here, it is equivalent, if you have in parentheses, it is equivalent to -3 times -3. Essentially, it is the quantity of the number being multiplied by itself twice. So as a result, since it is being multiplied by itself twice, both negative, that is now a positive 9. Very important you know that for your future endeavors if you desire to go that far. Now, you may think that there is no difference between that and the next one. It's very subtle. If you don't have the parentheses, it's just a -9, because it's basically just telling you, it's real stupid in my opinion, but it's there nevertheless. It's basically just telling you it is -1 multiplied by whatever 3 squared is, and therefore -1 times 9. And since it's a negative and a positive, it's -9. And you can see they're the same. So there's that. Likewise, right, if you have a cubic power and you're multiplying a negative value 3 times, you'll have a negative value. You learn that eventually as odd and even functions. Eventually you get into that. Cool. Hopefully you understood that. But if not, as always, ask questions. Jumping ahead here, I'm going to take it a little slow because this does start to become a little more interesting in a way, and you probably will hate it a little bit. Right? We all know the special case of a number to the power of 0. That is simply 1. What then is this? What is that? You guessed right. It is a negative power. Well, I've never seen this before. What do you do? Allow me to enlighten you. Let's take 5 to the 3rd power, which you don't probably know off the top of your head, but it's 125. Maybe you did, maybe you didn't know that. 5 to the 3rd power is 125. Okay. 5 to the 2nd power, you may already know, is 25, right? That's an easy one, fairly. 5 to the 1st power is just 5. As I'm going down in my powers, and then eventually, right, 5 to the 0 is 1. As I'm going down, there is a sequence that is consistently happening every time I subtract an exponent or subtract one from the exponent or power. In this case, every time that I go down, I am dividing by 5. So I'll just put a /5 to represent that. From here down to this is divide by 5. And even going here to there, that still applies. I'm dividing by 5. So, logically, if I'm coming down to 5 to the -1st power, naturally, it is 1 divided by 5, or 1/5. Let's go again. 5 to the negative second power is 1 over 25, right? Because I've divided yet again. The other way to express a negative exponent, if I took just 5 to the negative first and 5 to the negative second again, let's scoot up here. You can represent it as such because you're already kind of seeing it anyway. It's 1 divided by 5. It's to the first power, but it's in the denominator. Likewise, 5 to the negative second is 1 over 5 squared in the denominator. So it is literally taking the power and dividing it. That's all it is. Nothing crazy. And it becomes a fraction. Now it's to the point where yet again you have sufficient information for what is to come next. And that is something that is so important. And it is essentially power rules and operations between powers. We have 5 squared times 5 to the first power. Well, we could expand and say, well, it's 25 times 5. And then you'll get your answer of 125. Valid. But there is an easier way to do it off the rip, especially if these numbers have the same base value. And all you have to do when you are multiplying numbers with the same base value is you add both of them together into the same base exponent. And it makes sense. Hey, I'm just multiplying 5 into 5 squared, and I'm getting essentially 5 cubed, right? 5 to the third power. I'm just multiplying another 5 to a square of 5. So anytime you see the base value and you're multiplying it together, you are simply adding up the exponents and combining them into the same base. Division is the exact same way, right? Let's do 6 to the fourth power divided by, I'll do this one because you're going to see this a lot more often. Divided by 6 to the first power. Same thing, just backwards. Instead of adding, you are now subtracting. So that is equal to 6 to the fourth minus 1, which is 6 to the third power. You tell me how this goes in your head. I'll give you a few seconds. Let's do 5 again. But this time, is this. And I'm going to split this up too. Excuse me. I know I'm a mess sometimes. Right, here's your problem. You may or may not have pieced it together based on the rules that I've given you. Simply that. You're basically subtracting again. So 5 to the first power, and it's 5. Right? And it is the opposite for division. If you are dividing these exponents with the same base, and then you're just flipping the script. You're subtracting a negative number, you're adding those exponents. Now, you might be asking the question in your head, I'm going to scoot up here. Well, okay, we have the same base for the exponents. What if I have different ones? Like, okay, what if I have 3 to like the second power, and I'm multiplying it by 5 to the second power? Well, newsflash, you can't. You would need a calculator essentially to figure that out, but you can't simplify the expression the way that we did with the others. This is absolutely possible and doable. It's just there's no tricks to simplify this. You'd be in a better situation if you had, for example, like 3 squared, and then I want to say like 9 to the, let's say, the fourth power or something like that. Because you have bases that can be broken down, and 9 can change into a base of 3 if you did the right math. That is beyond the scope of this lesson, and to be honest, I'm kind of suspicious about that. I think I did that wrong. But essentially, you have to have bases that are somewhat related to each other and able to factor into each other as powers. That's beyond the scope of this. That is more, I'd say, algebra 2-ish, algebra 1, 2. Regardless of the case, it's beyond the scope of what I'm trying to teach. I'm just trying to get your questions answered if you were to have any, or any that I can think of.